we are going to start off with homework number 18, and it is called Roots and Radicals. And I included a picture of a tree, and you see all of its roots. That's a real picture, right? It's cool being able to see how far like a tree's roots go down into, and although we're not obviously talking about nature and talking about the roots of a tree, right? We want to find the roots of different numbers. Particularly, we'll be talking about square roots and cube roots, but we'll also talk about fourth roots, fifth roots, etc. Okay, you've heard of square roots before. Some of you may have heard of cube root. And there's a picture on the homework if you direct your attention to it. And I can just draw it here on the board. Right, you have like the square root symbol. And then one thing that might look a little different is this number right here. See this number? That number is not typically there if you're using the square root. Okay, it's just there. It's supposed to be there, but people just took a shortcut and said, hey, I'm just going to take that number out. Because it could be a 3, it could be a 4, it could be a 5. If you just see like this symbol right there, that's the same exact thing as that. Right? So you might see just the square root and it look like this, but it could also look like that. All right. So going back to our original, I guess, up here, we're looking at this. There's different parts of this, I guess, of this root, right? And we're looking at not only that 2, not only that symbol, not only that X, not only the equal sign and the Z, we're looking at all of it, okay? Starting off, that 2 right there, the name for it is an index. If we're being specific and we're learning math vocabulary, you see that if I ask you, what's the index? You would say, you look at that and say, oh, the index is 2. Okay, then we have the actual symbol, right? This over here that we were just talking about, that symbol where it kind of looks like a check mark with an extended line across the top, that is called the radical symbol. And some of you may have heard the word radical in a different context, but in math, that's what a radical symbol is. A radical symbol. You know, my handwriting isn't the best. That's an R. Radical symbol. And then what's on the bottom, some of you may have learned this in Algebra 1. I'm not sure if your Algebra 1 teacher ever taught you this, but we'll review it. This is called the radicand. Okay, so you have your index, you have your radical symbol, your radicand, and what you finally get in the end, what you're trying to find, this right here, which is Z, that's your root. Okay. And we've already dealt with square roots before, briefly, right? We tried to find the square root of 25, the square root of 4, the square root of 9, and you guys were breaking down these radicals. You are breaking them down and finding the square root of them. So like, for example, we dealt with the square root of 4, which is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. I mean, I could go on forever, but these are just a few that we've dealt with pretty frequently. Okay. And many of you have these memorized because 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. It's just your multiplication tables. Usually in 3rd grade, you learn multiplication tables, right? my daughter is just starting, she's in second grade, just starting to understand a little bit about multiplication. You typically like get the flashcards out and start memorizing them in third grade. So you're introduced to your multiplication tables, and you learn them and you memorize them the same way you've memorized a lot of addition, right? When you first start off learning, you start counting on your fingers and trying things out. And then your teacher says, no, you can't count on your fingers anymore, right? You can't use them. And then you got to start figuring things out, memorizing, okay? All of you usually memorize things through repetition. Repetition is a good way to memorize. So in this, I'm going to continue to go through this repeatedly, and I expect that you guys will follow along. And if you guys have questions, make sure to ask them. Okay, so I'm just identifying the different parts of your radical. Okay, so we have the index, which is the 2 that's up there. We have our radicand, which is on the bottom. Okay, you have your radical symbol. It's a check mark with the line over top of it. And you got your root, which is what you're finally trying to find, right? And we just used a letter. We use Z. It's not always going to be Z. It's not always going to be X. Okay. So knowing that, also I have in your homework, there's it says key concept, the nth root. Okay. Whenever you find the square root of a number, okay, whenever you find the square root, let's say I find the square root of 4. Really, that's trying to find out what number times itself equals 4. And a lot of you might just say, okay, yeah, 2. 2's the answer there, right? But couldn't it also be -2? What's -2 times -2? 4. 4. Okay. So whenever you take the square root, and remember this symbol, right? This radical symbol, typically we don't write that 2 there, but there is like a hidden 2. The same way as when we write X, there's actually a raised to the first power. Okay. So we've written it so many times and we use it so frequently that we just stopped writing that 2 out in front. Okay. But when you find the square root of a number, say the square root of 9, right? That could be 3 or -3. Technically, right? Because -3 times -3 is 9. So whenever that number out in front here, whenever that index is I'll say, when the index is even, whenever that index is even, you're going to have 2 answers. One is going to be positive, and one is going to be negative. Okay. So whenever that index is even, now, whenever the index is odd, well, what does that mean? Well, what if I find the cube root of a number, right? What if I find the cube root of 8? What that really means is, remember, square root, it was itself multiplied by itself. But a cube root would be what number takes itself, multiplies it by itself, multiplies itself again. So it would be something times something times something, right? And we can do the math, but the cube root of 8, the cube root of 8 is 2. Because 2 times 2 is 4, times 2 is 8. I don't expect you to memorize this. That's why you have this. Okay. So I want you to take out your calculator right now. And I'm going to walk you through a few things. All right. So if you look on your calculator, you'll see your graphing calculator, TI-83, TI-84. You'll see the second button in the very top left of your screen. It says second. Mine is yellow. If you press second, what symbol is right above x squared in yellow? Or whatever color? The radical symbol, right? So that's how you would use the square root. So if I want to find the square root of 36, I would click second. I'd find the radical symbol and click it, and then type in 36. And I can close parentheses if I want. It's usually best practice to close the parentheses and then click enter, and it gives me 6. Okay. So that's the square root. Look at your calculator. Do you see a cube root anywhere? Nope. Guess what? Click math. Math is right below alpha. Now do you see it? Okay. So you go down to cube root, which is 4 for me, and then find the cube root of 8. And it gives you 2. Okay. So whenever we're using an odd index, right, you're only going to have one answer. And it could be positive or negative. I'll explain what that means in a little bit. Don't worry too much about that. I guess if I were to find, I'll explain it right now, actually. If I were to find the cube root of negative 8, remember we talked about the square root of negative 1? The square root, not the cube root, the square root. So don't look at this and be like, oh, there has to be an I in the answer. Wrong. This is a cube root. Okay? Because I can take negative 2 times negative 2, which is positive 4, times negative 2 again, which gives me a negative 8. So the cube root of negative 8 is negative 2. And you can test that by putting it in your calculator. The cube root of negative 8 is negative 2. Okay, so going back to this over here, what I just, this box I'm drawing around, when that index is even, you're going to have two answers. One's going to be positive, one's going to be negative. Okay, when the index is odd, you're going to have one answer, and it could be positive or negative, but not both. Okay, just making that clear. And I've showed you all that so we can finally get to, well, I'm going to backtrack. One thing, I want you to type the number 4 in your calculator. Just type it. Just type 4 and leave it there. And then click math. And look at the symbol right below the cube root symbol. For me, it shows like an X. And then the radical symbol. Do you guys see that? That just means, hey, whatever number you just typed out in front of this, I'm going to use as that number. Okay. So if I want to find the fourth root of, let's say, 32 and click enter, it gives you 2.378, whatever. Okay. Or if I want to find the fourth root, I'll type in the 4 again, click math, and then go down to number 5 and say the fourth root of 16. What's the fourth root of 16? 2. Okay. So you can do that with any number. You can find the 5th root, 6th root, we learned the square root, which is just an index of 2, a cube root, which is an index of 3, but that number out in front could be anything. The popular ones are square root, cube root, so that's why they already have them in our calculator predetermined, but if you want to find other ones, you can. All right. That's important moving forward. So to recap, always make sure you're taking a look at that index out in front. Don't assume that it's a square root. All right, let's get into the problems. Look at number 1. Okay, number 1 says find all the real square roots of each number, not the imaginary, right? Let's find the real square roots. So it says the square root of 225, right? You probably don't know the square root of 225 off the top of your head. And if you look forward to number 2, the square root of 0.0049, right? Top of your head, probably not going to know that, right? But I want you to type in your calculator, what is the square root of 225? Okay, and the square root of 225, if you put it in your calculator, it tells you it's 15. But what did we just talk about? When you have an even index, really there's an imaginary 2 out in front there, right? Not imaginary, it's just there, right? Can't see it, it's hidden. Maybe the word should be hidden. Whenever we have an even index, we also need to find the negative, right? So it could be 15 or negative 15. That's my answer. Okay. Finding all the real. Number 2. Okay. It's asking me to find the square root of 0.0049. Okay. So you put this in your graphing calculator, find the square root of 0.0049. I know the square root of 49 is 7, right? But the answer is 0.07. Or negative 0.07. That's my answer. So we need to get in the habit when we're looking for the real square roots. That's what we're looking at. Okay. Number 3. We're still dealing with square roots. The square root of 2401. Okay, you can draw that 2 out in front if you feel like you're going to keep forgetting the index is 2. You can draw it out in front if you really want to. But the square root of 2401 is 49. Or negative 49. Because negative 49 times negative 49 gives you 2401. Okay. That's number 3. Number 4. Okay. Number 4 says find all the real cube roots of each number. Okay. So now the index out in front is no longer 2. Now you have to draw that 3 out in front. Okay. The cube root is negative 64. Now remember, on the last page that I drew out, I said if the index is odd, how many answers should I have? 1. Okay. So I should only have 1 answer. So the cube root of negative 64, I don't expect you to memorize that. You get out your graphing calculator, you click math, you go down to the 4, which is the cube root, and you type in negative 64. Don't forget the negative. And my answer is negative 4. All right. Number 5. Number 5, I have 0.125, and I'm finding the cube root of it, 0.125. So the same thing, I'm putting in my graphing calculator, get in the habit of doing it on your own as well. So that way you know where to go and don't forget where to go. Comes test day and you say, I don't know where to go on my graphing calculator. You spend a lot of time going through it. Cube root of 0.125 equals 0.5. Okay, we'll do one more, number 6. Number 6, it says, what is the cube root of 729? Okay, so I'm going to click on math, go down to 4, the cube root of 729, and that gives me 9, which means 9 times 9 times 9, 9 times 9 is 81, right? 81 times 9 is 729. Okay, so remember, when we're going through this, the cube root of something, right? 9 times 9 times 9 gives you 729. Okay, 0.5 times 0.5 times 0.5 will give you 0.125. -4 times -4 times -4 will give you -64. Okay. So that's literally how they probably made up those numbers for the problem. Like, where do they even pick these numbers from? Someone probably worked backwards and said, hey, I want the answer to be 9. I want to find the cube root of it. 9 times 9 times 9 is 729. All right, I'll make them find the cube root of 729. That's what I do when I make up problems as well. Okay. Don't just pick a random number off the top of my head. I work backwards from the answer. Okay. Number 7. Number 7 says, find all the real fourth roots of each number. Okay. So the fourth root of 16. We actually already did this one, but my index is even. How many answers should I have? Should have 2, right? So if you go in your calculator, first you type a 4. Just type 4, and then click on math. For me, it's the 5th one down. It's just like an X with that radical symbol. And the fourth root of 16 is 2. Or -2. Now, here's the reason why. -2 times -2 times -2 times -2 is equal to 16. -2 times -2 is +4. +4 times -2 is -8. -8 times -2 is +16. Right? So that's a real solution. Okay, one more. Number 8. What is the fourth root of 0.0081? Okay. So I'm going to do the same thing. I'm going to type in 4. I'm going to click on math. I'm going to go down. Mine's the 5th option down. There's an X next to that radical symbol. And then I'm going to type in 0.0081. Click enter, and I get 0.3 or -0.3. Right? Your calculator won't tell you the or, but we know, oh yeah, we can figure out this answer. Okay. All right. Moving on. Number 9. Number 9 says, find each real root. And it gives you the square root of 36. Right? What's the square root of 36? What times what is 36? 6, right? Remember that that index is actually even, right? There's a 2 there, right? So it's going to be 6 or -6. Okay, number 10, the square root of 0.25. This is a bit of a continuation from the last few problems, but now I've mixed them all up where I have some square roots, I have some third roots or cube roots, I have some fourth roots as well. Okay, the square root of 0.25. I don't like the way that 0 looks. 0.25. Okay, the square root of 0.25 is 0.5 or -0.5. I anticipate that when we have the test, some of you may forget and only give me 0.5 as the answer, rather than I've asked you specifically each real root. And for real numbers, you have to realize that when you have a even index, that you need to also provide me a second negative answer. Okay. 11, I want to find the third root, which is the cube root of 64. Okay, so I'm going to go on my calculator, use my cube root symbol to 64, and that gives me 4. Am I good, or should I include another answer? Good. Why? Index is odd. That's all I need to say. Index is odd. All right. So if my index is even for the next 4096, right? How many answers should I have? I'm going to have 2, right? So I type in my 4, I go to math, find my radical symbol, and I type in 4096, and I get 8 or -8. All right. So that's like kind of like basic. All right, we're getting into radicals. Now let's step it up a notch. All right, just a little bit. Let's turn it up just a little bit. Number 13. Number 13 says, I want to find the cube root of 27 y to the 6th power. Okay, so the cube root of 27 y to the 6th. Now we're starting to include variables in here, right? So the first thing I want to do is I want to look at this as if there's no variables, right? If there were no variables and it was just the cube root of 27, how many answers would I get? Would I get 1 or 2? 1, because the index is odd. Okay. What is the cube root of 27? Well, I know 3 times 3 is 9 times 3 is 27. So the cube root of 27 is 3. Okay. Now, what we're trying to find. So really think of this, right? I found the cube root of 27. And let's say also I want to find the cube root of y to the 6th power. What I would do is I would say, all right, if I want to find the cube root of y to the 6th, that would also be the same thing as saying, I can break this down even further, and I can say that's the same as saying the cube root of y to, let's just say, I don't know if I want to write it like that. I was going to write it a specific way, but I'll leave it. I'll say, yeah, I won't do it that way. Okay. So what you're going to do is you're going to look at this and you're going to say, all right, I can take this out I can find the cube root of y to the 6th power. And the way I can find that is by saying y squared. Okay, because 3 times 2 gives me 6. All right. 3 times 2 gives me 6. So my answer here would be 3 times y squared. Okay. Let's move on. Number 14. Number 14 gives me the 5th root of 32 y to the 10th power. Okay. So what I'm going to do is I'm going to find the 5th root of 32. The 5th root of 32 is really 2. And then 5 times what equals 10? It would be 2. Okay, so my answer is 2y squared. All right. Moving on from here. Next one, number 15. Number 15 is the cube root of 125 y to the 9th. Okay, the cube root of 125 y to the 9th. So what that would give me is the cube root of 125. 5 times 5 is 25, times 5 is 125. The cube root of 125 is 5. And the cube root of 9 of y to the 9th power is y to the 3rd. Because 3 times 3 is 9. All right. Moving forward, number 16. Okay, number 16 tells me that if I have the square root of 8 times the square root of 32, the instructions tell me to multiply if possible, then simplify. Okay, so if I'm looking at this problem, I have the square root of 8 times the square root of 32. In order to solve this, what I can do is I can just multiply 8 times 32 and just put it inside here like this. So 8 times 32, if I take out, you don't have to have it memorized, 8 times 32 gives you 256. Now that we're here, we find the square root of 256, and that equals 16. Okay, so when you're multiplying two square roots together, okay, you can just combine them, multiply whatever's in the radicand, 8 times 32, and then you get whatever that number is. 8 times 32 is 256. All right. Same goes for number 17. If I have the cube root of 4 times the cube root of 16, 4 times 16 is 64. And the cube root of 64 is 4. Okay, so that was my answer for this one. This is my answer for this one. All right, number 18. Look at number 18, and we have the cube root of 12 times the cube root of 18. Now, this will only work if you have the same index, right? You can only combine them like that if you have the same index. They're exactly the same. I can combine them. 12 times 18 gives me 216. And the cube root of 216 is 6. I guess all I needed to circle over here was 16. All I need to circle over here was 4. This is 6. All right. Last two. We're going to number 19. 19 just says simplify. Okay. Now, if I'm simplifying, we're going to look at what we're simplifying. The square root of 20x to the third. My index, remember, if it's just a square root symbol, my index is 2. Okay. Now, before, remember how in the past few examples, I just gave you an easy number to find the square root of. So I said, like, what's the square root of 25? You just said 5. What's the square root of 20? You don't know off the top of your head, right? So remember that we can find the square root. We can break things down, right? This is the same as saying, well, what's a number that I can easily find the square root of? That's a factor of 20. Factor of 20 are 1 and 20. No. 2 and 10. Nope. What about 4? Can I find the square root of 4 pretty easily? Yep. So let's do this. What's the square root of 4 times the square root of 5? Remember how in the last example, we can combine those two together to give me the square root of 20? So I can also write it like that. Times the square root of x squared times the square root of x. Okay. The reason why I wrote this out like this, right, x squared times x, is because I can easily find the square root of the same root. So if I find the square root of a number and square it, that's just like canceling itself out. And that just leaves me with x. So the square root of x squared is just x. The square root of 4 is 2. Square root of 5 is a decimal. And the square root of x. So I multiply all these together. I get 2x times the square root of 5x. That's my answer. Okay, we'll do this again. Number 20. Okay, I have the cube root of 81x to the third. Now I can find the cube root of 81. The cube root, oh, I'm sorry. The cube root of 81 is actually a decimal. But what I can do is I can look what are the factors of 81 that I can find the cube root of, right? So let's say if I'm looking at this, I can break this down. And if I find the cube root of 27 times the cube root of 3, if we're listening to all the factors of 81, that's actually one of them, right? So let's say the factors of 81. We have 1 and 81. 2, no. It's not divisible by 3. We have 3 and 27. Okay, those are factors. So since those are factors, I can list 27 times 3 as 81, right? So I'll go ahead and transport all this down here. I'll just say the cube root of 27 times the cube root of 3 times the cube root of x to the third. Okay, the cube root of 27 we know is 3. 3 times 3 is 9, times 3 is 27. Cube root of 3 is going to be a decimal. But the cube root of x to the third, you can cancel that out, and that leaves you just with x. So my answer, what that would leave me with, is 3x times the cube root of 3. Okay. So once again, how did I break that down? I listed the factors of 81. I did that part originally in my head, and I was like, I should probably write this out, right? The factors of 81. And I realized, oh, 27, 3 times 3 times 3 is 27, the cube root. I can use that. Also, something important, like I said, if you find the cube root of a number that's also raised to the third power, that just cancels each other out, right? Same way up here at the very top, right? If I have the square root of a number squared, that just cancels each other out and leaves you with x. All right. And that's what I get.